question came in year 2013. This is QT is the output related to capital stock KT and labor supply LT. And you're given this equation. This is find the rate of growth of output. Actually, this is not from chapter 15, but from chapter 16. So you can look at this question after completing chapter 16 videos, because I'm going to use chain rule in this. Okay. Now just look here. Now just look here, okay? So I have to find the rate of growth of output. Now what am I saying? I am saying that there is output defined by Q, and output can change because of two reasons. Either it can change when capital changes or when labor changes. Can you see this? Output can change when capital changes or labor changes. But capital can change when there is a change in time. Capital is a function of T. And labor can change when there is a change in time. Labor is also a function of T. So now what we go ahead and do is, because we are finding the rate of growth of output, which means how output changes over time. So we are finding how output changes over time, T. So we are saying that how output changes over time is equal to output can change because of capital into capital can change because of time. Output can change because of labor into labor can change because of time. So now, very simple. I have this equation given to me. From this equation, I can go ahead and find del Q by del K, and I can find del Q by del T by del L. Just do that. What will be del Q by del K? Differentiate this function with respect to K. So A e to the power alpha T, this is a constant. And when I differentiate this with respect to K, the power of K will come down. This is actually multiplication in the question, sorry. The power of K will come down. So beta will come down and its power will reduce by 1. So this is its differentiation with respect to K. Into, what did we say? How K changes with respect to time. So this is K dash T. dk by dt is written as K dash T. Similarly, you change output with respect to L. So the power of L will come down and it will reduce by 1. So power of L comes down and it reduces by 1 into how labor changes with this all is constant, of course. How labor changes with respect to time. So L dash T. Now, please see what I am doing next. See, if you notice, then this part here, this KT to the power beta minus 1, this is nothing but it is KT to the power beta into KT to the power minus 1. Isn't it? And this LT to the power 1 minus beta minus 1, this is to the power 1 minus beta into LT to the power minus 1. Once I do that, I can take KT to the power beta and LT to the power beta minus 1 common from the two sides. So I have A e to the power alpha T common. This I already had. I have taken KT to the power beta common because this can be opened up like this. I have taken LT to the power 1 minus beta common. And here I am left up with beta, KT to the power minus 1 into K dash T plus 1 minus beta, LT to the power minus 1 into L dash T. Just understand this thing first, please. So this is very, very simple. We are just trying to differentiate this function with respect to capital and labor. When I differentiate it with respect to capital, I take the power of the beta down and reduce it by 1. And then when I differentiate with respect to labor, I get this power down and reduce it by 1. So I have been able to get this. Now, this part actually is nothing but my output. So I've written output. And this part, kt to the power minus 1, this is 1 by kt. Anything to the negative power is just 1 by kt. So this is 1 by kt. Into k dash t. This is nothing but how capital changes with respect to time. Now, we have in economics something which is known as growth of a variable. And growth of any variable is basically 1 by that variable into how that variable changes over time. So if you will notice, this becomes the growth of capital. This becomes the growth of labor. And if I take this Q on the other side, this becomes the growth of output. So I get growth of output is equal to GK, growth of capital into beta, plus 1 minus beta, growth of labor. So this is how you can go ahead and solve this question. Is this clear? It is a very good question. You were given a production function. The production function is a function of time. And this is A e to the power alpha t, kt to the power beta, lt to the power 1 minus beta. You have to check how this output changes over time. So we say output changes because of capital and labor, which in turn changes because of time. So we said that the change in output over time is how output changes with respect to capital into dk by dt plus how output changes with respect to labor into dl by dt. This part is just differentiation of this with respect to capital. So this part is nothing, a e to the power alpha t, beta comes down, kt to the power beta minus 1, lt to the power 1 minus beta, into dk by dt's short form is written as k dash t plus. Then you have to differentiate with respect to labor. So a e to the power alpha t, kt to the power beta, power of this comes down, lt to the power 1 minus beta minus 1 into l dash t. Then I said that you should take this common, and kt to the power beta minus 1 is nothing but kt to the power beta into kt to the power minus 1. So you can take this kt also common from here and here. Then you will be left up with kt to the power minus 1 here. Similarly, this can be written as lt to the power 1 minus beta into lt to the power minus 1. So you can take this common. And after taking common, you would have got a e to the power alpha t, kt to the power beta, lt to the power 1 minus beta into beta k dash t upon kt plus 1 minus beta L dash t, since they have negative power, right? So upon LT. Then this was simple. I called this as output. Beta, this is the growth rate of capital, plus 1 minus beta, this is the growth rate of labor, and this was dq by dt. I took this here and this became 1 by q. And then I just made this as the growth rate of output. And this was the derivation. Okay. Okay, let's go to the next question.